Alright, today we're going to start with logs. Now, logarithms are multiplied exponents. So you have to remember your exponential laws as well as the logarithmic laws because they're intertwined. We'll just go over those right quick. Power rule. Power rule says that if you have two exponents in the same base and you're multiplying, what do you do to the exponents? You add them together. Quotient rule. Says that if you have two exponents and with the same base and you're dividing, what do you do to them? You subtract them. Power rule says that if you have an exponent raised to an exponent, what do you do with them? You multiply them. Now all three of these rules have something to do with the mechanics of the exponent. In other words, how to work it, how to manipulate it. The next two are kind of aesthetics, for aesthetics, in other words, make it look better. Because what do we not like? We do not like negative exponents. Whenever we're dealing with a negative exponent, we usually find a way to rewrite it to where it's a positive exponent. So, the fourth one's called the inverse rule. The inverse rule says if I have an exponent and it's to the negative power, I can flip it and it becomes positive. And if I have an exponent that's negative up top, I flip it and it becomes positive. So that is the inverse rule. And then number 5 is the inverse power rule. And the inverse power rule is somewhat different from the inverse rule because it has the parentheses. So I can have a to the n over a to the m raised to the negative w power. And I'm focusing on that negative w. If I flip what's on the inside of the parentheses, the w becomes positive. Now a lot of people say, well I thought you said that if you flip this, that would be a to the negative m over an a to the negative m. No, because this is not the same as this. What's the difference in this and this? This one has what? It's different from this. So when you flip these, it doesn't change the sign of these, it changes the sign of the outside exponent. So a to the n over a to the n raised to the positive is the power. Now those are your 5 basic rules of exponents. Now I'm going to show you how they relate to the exponential rules, but first I want to show you the definition of a logarithm. In this next slide, or next, I've got to remember how to bring them in. The mouse is not working too good. That's the definition of a logarithm. Now just pick one. I don't care which one you pick. The one that's mostly used is this one. This computer is not working well today. Alright, I've never used z is equal to, I've never used this before. So you need to write that down and put on the outside of it, definition of a logarithm. And you're going to have to memorize this. Y is equal to log base b of x can be rewritten as b to the y is equal to x. Sometimes you might see y is equal to log base a of x. A to the y is equal to x. That's how I remember it. It depends on what kind of book you're using. But that's the first rule that you need to memorize having to deal with logarithms. It's not a question of if, it's a question of you learn it, you pass, you don't learn it, you fail. That's pretty simple. And I'll just pull that over. So the definition of a logarithm, either one of those, doesn't matter, just memorize one of them, whichever one you want to memorize. And then the rules for logarithms are right there. And notice how they compare to the exponential properties. There's power rule, product rule, product rule. What do you do when you multiply logarithms? You add them if they have the same log base. What do you do with the quotient rule? When you divide, you subtract. When you divide, you what? Subtract. I don't know why there's a question mark there. It's supposed to be subtract. Power rule. If you have a variable raised to a power, raised to a power, you multiply it. Here, this is a little bit different. If you have an exponent, you can bring that exponent out front, like that. And then these two are identities. Anytime these two match, the base, log base 10 of 10 is 1. Log base 4 of 4 is 1. Log base 2 of 2 is 1. Log base 101 of 101 is 1. And any log of 1 is what? 0. You need to write those down and make that change right there. It's supposed to be minus. I don't know why it's a question mark. I guess they hit the wrong thing when they made it. Question mark ain't nowhere near the, I don't know. Who knows? Now, most of the time in this section, or in this chapter, you're going to learn how to rewrite and manipulate logarithms. That's the first thing you're going to learn. All right? The second thing you're going to learn is how to solve equations. Okay? And you're going to learn to rewrite using the definition and these things right here. Well, these first three. And then you're going to learn to solve by turning the equation into one of these or one of these. So, and you're going to learn about the natural log. Let's go ahead and talk about the natural log. We'll do that when we turn to the next page. There's only two, get your calculators out, there's only two keys on your calculator having to do with logs. And they are LOG and LN. Now, if you want to go back into history and find out why we have it, just you do that on your own. I'm not going to even answer it because it's too long to go into. But LOG is log base 10. And if it's not there, it's understood to be log base 10. Natural log is log base E. And E is equal to 2.7, blah, 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 blah. Now those are the only two buttons on your calculator. So these are the only two that can be calculated with your calculator. Does all the previous rules correspond with the natural log? Yes. They all correspond to the natural log. I'm an LOG. I like using LOG because when natural log comes into the problem, I can always substitute LOG base E, and I can deal with LOG a whole lot better than I deal with natural log. But it's just personal preference at this point. Doesn't really matter. What if you have log base 2 of 5? Well, if you ever come up with one of these, you cannot do it in your calculator. You have to use what's called the change base formula. And the change base formula, I'll pull it up for you, since our book doesn't work. Is basically take the log of the base, log of the number over the log of the base. Let's see if I can find a good one. There it is. I guess I got a small one there. Okay? If you have log base 2 of 5, then that's going to be log of 5 over the log of 2. And LOG, when nothing's there, is assumed to be what? Log base 10. So these are log base 10s right here. Log base 2 of 5 equals the log of 5 over the log of 2. What about natural log? Same thing. Natural log of 5 over natural log of 2. So write this down. That's added to your properties as the change base formula. Now basically, when we study, I'm going to go back to the definition of a logarithm. There's the definition of a logarithm right there. We're talking, Oh, I'm sorry. We're talking about a glorified exponent. When you graph y is equal to x squared, you got a parabola and it looks something like that. And everybody knows what that looks like. But when you graph y is equal to 2 to the x, what kind of graph are you going to have? Well, you're going to have a graph that's going to be growing what? You ever heard of growing exponentially? Think about it. 2 to the first is 2. No big deal. A little graph here. 2 to the 2. 2 to the third is what? 8. 2 to the fourth is 2 to the fifth is 32. See what it's doing? It's taking off. Alright? So you're talking about either a exponential is either growing really fast or it's dying really fast. It's either growing really fast or it's what? Dying really fast. This is x or some number a to the x power, and this is a to the what? Negative x power. This is growth, and this is what? Decay. Now some of you remember some of this in your high school algebra classes when you studied about carbon life, whatever it's called, carbon dating, and when you talked about interest. That doesn't look right. I don't know what I'm talking about. Carbon dating. And also plutonium, or you talked about half-lives of batteries or half-life. And this was mostly interest. And you're again talking about right there. So, again, since we don't have our book, we can work on some problems if I can find some. Just give me a second to find some. Alright, let's take a couple of these. Let's do real simple A, B, and C. Do A, B, and C. 1, A, B, and C right here. Can you see it okay? Right here. Real simple. These are definition of a logarithm. You might want to write it as 9 is equal to log base 3 of x. I'll start you off with the first one. Before I do, though, let me pull up my handy dandy. Okay, so I don't use this one, I use this one. So I'm going to write my y first. I'm going to write it right up under. Hold on a minute. I'm going to write my problem. This is the Hebrewism. This is what I used to do as a student. Okay? For those that are listening, take your y and your b and your x, and now what am I going to do? Huh? That means I'm interacting with y'all. That means it's not rhetorical. Put it in this form. If your problem is in this form, then you're going to write the answer in this form. Not rocket science. Okay? So what's my b? 3 to the 9 is equal to x. And that's some BA number. You can do that with a calculator. And what they're getting used to, what they're trying to get you to do is to be able to change it real quick. So this would be 2 to the what? 2 to the x is equal to what? 8. So you gotta put it right up under here. So you do it again. So log base 2 equal to x. Log base 2 of 8 is equal to x. So 2 is b. 2 to the x is equal to what? Now, this brings up, how do I solve that? Well, a lot of people have forgotten how to solve it. So we'll just copy it. Take it over here. And I'm just going to pull this out right here because that's what we, just in case somebody has forgotten how to solve that, always remember if you have an x and an exponent, you have to rewrite as what? And you have a variable and an exponent. then you're going to have to rewrite the 8. Why the 8? Well, that's the only thing left as an exponent. So how can you rewrite 8 as an exponent? And it kind of helped, meaning sarcastically, to have the same base also. So what's the base of this exponent right here? So let's rewrite this as 2 to an exponent. What would it be? Thank you. Should be 15 people saying that together. And here's the rule that people forget. When you have the same base equal to each other, the exponents what? Are equal to each other. So in that equation right here, x is equal to what? 3. So take the calculator. So we're saying that 3 is equal to log base 2 of 8. Well, we can't do this in our calculator. We've got to take it to the change base formula, which 3 is equal to log of 8 over the log of 2. Now you can do this in your calculator and see what you get. Log of 8 divided by the log of 2. What do you get? Huh? It's a miracle. All right, try the last one. Log base 3 of 27 is equal to x. Yes, ma'am.
I got 1.42. I'm not sure where I did that from.
You're a loser.
I have the same thing.
You live in a ditch. They got many, yeah, they got a lot of ditches down in eastern Ireland.
Better be lucky your truck didn't slide off that icy road and hit a tree like I did.
I'm sorry. Well, it kind of, the reason you got the wrong answer is you're putting the 8 inside the parentheses. So the calculator is thinking you're taking 8, dividing by the log of 2, and then taking the log of that.
Well, it did that on all the things itself. You just did log 8.
Okay, close parentheses. Okay, divided by.
Log
And close parentheses. It's a miracle. Did you get that, Miss Evans?
Yeah, come back to this one.
Log of 8. 8. And then close parentheses. Divided by log of 2. Yep. And now you can check it. Yes, sir.
When did we go back to high school?
What are you talking about?
The paper airplanes.
I don't know. I don't know where this comes from. Don't ask me. There's no telling.
Figured it might have been your last class.
No. They were in here when I came in here today.
Interesting.
Okay. So our next problem says x is equal to log base 3 of 27. So 3 to the x is equal to what? 27. Yeah. So we've got to write 27 in respect to 3. So 3 to the x is equal to 3 to the third, and again x is equal to 3. So if you take the log of 27 divided by the log of 3, you're going to get 3 again. But you can also go in the other direction. So let's do A, B, and C on number 2. C, number 2. Oh, sorry. So y is equal to 3 to the 4th. So I'm going to rewrite it as 3 to the 4 is equal to what? Y. So b is 3. Y is what? 4. And in this case, y is what? X. So, wait a minute, did I get it past backwards? Okay, so that's going to be X. And that's something I don't like when they put the Y's and the X's in there. They need to use different variables because it messes a lot of people up. Now this one, if you wanted to solve it, you would go along the lines of the change base formula and say 4 is equal to the log of x over the log of 3, and then multiply both sides by the log of 3. Well, we'll give them that later. We don't need to get the cart before the horse. Yes?
So like on those, did they just want us to change them to console?
Yeah.
Or did they want
Yeah, it says write in logarithmic form. Some of them you will be able to, depends on where they put the x. So the next one is 3 to the x is equal to 27. So y is equal to, or x is equal to, put the x there, log base what? 3 is t, of what? 27. Oops. Now, you could, yeah, we've already done it. You could rewrite this as 3 to the 3rd and bring the 3 out, and log base 3 of 3 is 1, and 1 times 3 is what? 3. So you could actually do these. Okay? So there's 2 or 3 ways you could do it. You could do log base 27, log of 27 over the log of 3 and do it with the calculator. Or you could say log base 3 of 3 to the 3rd power. That 3 comes out. And what's log base 3 of 3? 1. And what's 1 times 3? Either way, you're going to get 3. I'm just saying that you could do both of these 2 different ways if you were solving. But that's the answer right there. Okay? And then the last one, m is equal to 4 to the 2nd power. So 4 to the 2nd power is equal to m. Y is what? 2 log base 4 of m. And you really just Let's leave it like that because we haven't got to the solving yet.
How do you know to replace the X with N?
This is what you do. You put it under the equation, under the definition. You can see it right there. Hold on. Okay. So here's what you're given. Just draw an arrow down. And then you plug it over here. What's y? Log. What is b? And next. All right, now we got something like this. What do? Well, it says use the logarithm to what? Okay, does it say the other S word? What is the other S word? Solve. It does not say solve. So you need to chill out. Okay, it says simplify. That means you're going to rewrite it. Okay? Now, that means you're going to pull in not only this guy, but you're going to pull in the other guys too. You don't need to do this. These guys right here. So, first of all, just pick it, what is that right there? That's a minus symbol. So that means that we can rewrite this in terms of minus, we can rewrite it as what? Division, because that's a minus symbol right here. Now, in order for you to be able to do this, these have to be the same log basis. Are they? Yes. So I can rewrite this one, and we'll just take this one over to the side. Log base 2 xy minus log base 2 of x squared. And I'm going to take, since this is a minus, I'm going to use this right here. And I'm going to say log base 2 of xy over what? X squared. Now, isn't that more simple than this? Now, you could, now I don't think they want you to because then you'd be re-expanding it. This could be written as log base 2 of x plus log base 2 of y, but they're not wanting you to do that because then you would be re-expanding and then simplifying after you re-expand it. So I think what they're wanting you to do is just notice this and put it right there. Okay? There's another way you could rewrite it, and that's to bring the 2 out, but again, you would be re-expanding it, and I don't think they want you to do that. So that's how you would do that right. Okay? Some of you play a musical instrument. Okay? One of the biggest problems with some musical instruments, like a guitar and I don't know about I don't know about woodwind or I don't know about them, but as far as guitar or piano, what's one of the most important things you need to learn how to do before you even learn how to play the notes? Where to put what? Where to put your fingers. It helps to be able to stretch your fingers to get that note on that octave up or whatever, and get the F and all that other stuff on the guitar. So it's like any other thing. First, you have to learn is that how you spell technique? Okay. First, you have to learn the technique. Then, you have to exercise the technique. Meaning, you have to actually try it and do it over and over and over again. And then, what comes with the exercise? Speed. Or in the case of playing guitar, playing the sound that says you don't suck at it. Alright? Versus somebody that sucks at it. You know what I'm saying? Now, a person that sucks at karate usually gets their butt whooped. Whether it's in a tournament or whether it's whatever. Alright? These three things. Does it go in this order or does it go in this order? It doesn't go in this order. Why do we even think of that? Because people want this. What? First. They want it first. And it doesn't work that way. Okay? Now, what in the world does this have to do with this? Well, I'm showing you the finger exercises right now. These and this in the change-based formula are the finger exercises. The recital is how to solve a logarithmic equation. And that's when you put all of this together. And the faster you are, the more of these you do, the faster you're going to be at solving an equation. And I tell you right now, 50% to 60% of your test is going to be solving logarithmic equations. No. Okay. So let's try this. This one says log base 2 of 8x squared over y plus log base 2 of 2xy. We're out of room. You get the roll while y'all are working on that one. I don't have it. I need to pull it up. Okay, Miss Anderson is here. Barron, you here? Orr is here. Crane. No Crane. Crenshaw. No Crenshaw. DeVore. Evans is here. Fisher. Hall. No Hall. Come on, please. Mouse is not working good. Keller's here. Lou. Lou, you awful quiet today. Still depressing working at Target.
Yeah, I just been trying to work at a fashion cafe.
Uh-huh. Did you quit Target?
Yeah, my last day was last Friday.
I was gonna say you just cuss out a customer, and that would probably do it for you.
Yeah, like they hired me as a hardline member, and the last 2 weeks I worked, they had me as a cashier.
More? Huh?
They like
Okay.
hard to explain.
I'll leave her.
They really had people
Nix?
that just hired doing my job.
No Nix.
So I don't know why they did that.
Pace was here. Paige? Not here. I think she's on hospital. Where's Mr. Pahala? Now he brings life to the class. A whole lot better. I wish he was in my first class. My first class sucks. Won't talk.
How you feel about that?
Pruitt is here. Sab, I didn't see Sab. Oh, there he is. Quiet as a mouse. Never says a word. Sloger is sick. Stone, Walton, and Woods. All right.
He was probably on a date somewhere.
Huh?
He was probably on a date somewhere.
All right.
Talking to girls.
So here's this problem. I don't know. These problems, I don't know who wrote them. They're from the internet, so who knows?
You can do it.
They're not exactly written like I would write them, because I would want to write them to solve it, to simplify, where I think they're writing them just to expand. Because it looks like to me he wants you to expand them, or she, whoever wrote this. Not one that I would actually pick, but we'll do whatever. Let me go ahead and copy this, because it's going to take a couple of steps. Sorry. When it's unclear, I have to go through this. There we go. And here, and there. Okay, so we're not simplifying, we're just rewriting. This means subtraction, and this means what? Addition. So we're going to expand this thing out. Log base 2 of 8 plus log base 2 of x squared minus what? Log base 2 of what? Of y. So that's this part right here. And technically, you could bring this where? Outside, because we're expanding it. And you could rewrite this as 2 to the second power and bring this out, and that'd be 2. But I don't know if they want you to go that far. So log 2 to the third. Sorry. Be 2 to the third. And that would be out front. That'd be 3 times 1 is 3. But we're not going to do that. Log base 2 of 8 plus 2 log base 2 of x minus log base 2 of y. And that's fully expanded this right here. Now, if we have the logs and we're adding these logs, what does that mean? Hold on a second, let me bring it in. If we're adding two logs, then we can rewrite that. See, it's going backwards here. Because we're given that, we need to expand it into that. So we're going to keep expanding. We're going to put a plus here. What is this going to be? Well, we got 3 here that's multiplying. So that'd be log base 2 of 2 plus what? Log base 2 of x plus what? Log base 2 of y. And that's all the way expanded. Now, again, there's a couple of things that we could do, and I'm going to put this in here because you need to be aware of it. This one right here can be rewritten as log base 2 of 2 to the third plus 2 log base 2 of x minus log base 2 of y plus, what's log base 2 of 2? 1 plus log base 2 of x plus log base 2 of y. And then what I do with that 3? Bring it out front, and log base 2 of 2 is 1. 3 times 1 is 3. Now, could you combine like terms? 3 plus 1, 4. 2 plus 1, 3. Minus log of 2 minus 1 plus 1. These two, what? Cancel. So that goes there, that goes there. Your final answer, if they want you to go, I don't know, is 4 plus what? 3 log base 2 of x. Okay, I'm not going to do any more of these problems, and I'll tell you why, because these are not the ones that you do on a test. Let me go back to the ones that we do on a test are going to be ones that you simplify. Okay, that's the equation. Okay, I guess they don't want to. Go ahead and do C.
Do you want us to write it the way we just did that one, or do you want us to?
Well, they want me to expand it because it's already in simplified terms. They want you to expand it, so go as far as you can.
Except do E?
Yeah, so that'd be log base 3 of 9 plus log base x, log, you know what I'm talking about. Just don't say it fast. Like saying Fuddruckers 5 times fast. when we come back Wednesday, we'll pull some problems out of the book. It's a whole lot. At least I'll know what they're doing. These, I think, are just going around the world, just showing you how to expand. Because they jump from here to here, and that's solving equations. That's a big jump. I'll go ahead and start summing you off. Log base 3 of 9 plus log base 3 of x to the 4 minus log base 3, well, actually, you have to bring 2 out. Minus 2 log base 3, or we could rewrite that as 3, could rewrite that as 9x squared. Yeah, we could do that. Let's do that.
You can't put that 4 up there, take the 4 to bring it from the bottom.
I'm going to. You give me time.
So we're working backwards.
Yeah, if you're going backwards, you're expanding. See, I was looking for some to condense. Well, he's got the one, or she, whoever wrote this, has got, these are the ones you condense, but he's also got equations. I don't want you to do that yet, because we don't know how to do that yet. So I thought he would put a, he's just not working with me, okay, or whoever this is, but this is. Just bear with me, okay? All right, so I'm going to make this 9x squared, and that'd be log
Push this off.
base 3. You got it. 9x squared. So log base 3 of 3 to the 2nd power plus 4 log base 3 of x minus log base 3 of 3 to the 2nd plus 2 log of x, base 3 of x, two times 1 is 2. Last time I checked, I think it was 2. 4 log base 3 of x minus 2 minus 2 log base 3 of x. So what's 4 log base 3 of x minus 2 log base 3 of x? Huh? Now, to answer your question, this problem, you should do what with it? Condense it. So, if I was to just, I'm not going to try to solve it. But this one, let me rewrite it. 2 log base b of 4 plus log base b of 5 squared equals log base, I went from this one to this one. I suck. Let's try that again. 2 log base b of 4. Y'all never done that, have you? Plus log base b of 5 minus log base b of 10 equals log base b of x. Now what tells you that you can condense this is they're all log base what? So that tells you you can do something with this. So the first thing I'm going to do is bring this out here. So that's going to be log base b of 4 to the 2nd power, 16, plus log base b of 5 minus log base b of 10 equals log base b of x. Okay, now I've got everything to where I can put it, all of them are log, there's no more exponents, there's no more coefficients out front. So this is log of 16 times what? 5 divided by what? So log base b of 16 times 5 divided by 10 is equal to log base b of x. Log base b of 8 equals log base b of x. So x is equal to what? So right now, you're learning how to place your fingers, and you're learning how to do the notes, but you haven't started putting it together yet. You're starting to put it together with this type problem here. But like I say, you're not going to be able to play until you learn all the properties. And then that's when you start working problem after problem after problem after problem. Yes?
Can you go back to the last answer that you did? I didn't get the answer and I looked and I'm like, oh no.
That one? These two cancel. And this is 4 boxes of cereal minus 2 boxes of cereal. Equals 2 boxes of cereal. I would tell you to do the rest of the worksheet, but just try to get online. What section? We'll have to look at what section. Somebody got syllabus, Andy? You got syllabus?
I had log 3 x 8.
I want to see the I just want to see the titles of the sections. Yeah, pretty much. I barely covered exponential functions. So I've covered 5.3. Yeah. So y'all should be working on 5.3 and maybe a little bit of 5.4. Okay? We'll cover the other stuff when we have the book. When I can pull it up. Y'all get out of here. Have a good day. Somebody hit my button for me.